The difference between the noobs and those making the biggest salaries and the biggest impact at companies comes down to 1. Single concept. But before we can understand this one fundamental concept, we need to name what is the difference between these noobs and pros in practice. Let's talk about the noob. As someone who struggled with computer science deeply for years and years, I can think of 3 things that were incredibly vexing. Number 1, I didn't really understand the fundamental building blocks I was working with. Second, if I needed to change one thing, the whole program would break. 3, when I wanted to change or fix or remove one piece of code, that code was so inextricably tangled with everything else, it behaved in wild and unexpected ways. What's the difference between the code noob and a code pro being paid a high salary? Well, it comes down to one thing, the Lego principle, which says, don't write code. Instead, use code to build blocks and build bigger blocks from those blocks and make sure it's easy to swap out a block and swap in another one. If you look at a super successful engineer, she's doing one thing really well that you can do right now. 1, she's building blocks. 2, she's using those blocks to build even bigger blocks. And 3, she makes sure it's easy to swap out any one piece, put in a new bug fix, or even an entirely new component without having to change everything else. These are not new ideas. You've probably heard and will definitely hear all these principles echoed again in every arena of programming. Barbara-Liskov substitution principle, class inheritance, modularity, decomposition, splitting things into microservices, MVC framework, separation of concerns. All of these are essential to being a good programmer. But the Lego principle is the essence uniting all of them. And understanding it will put you on the fast track to higher salary and bigger impact. The Lego principle is clearest in building Legos, so let's start there and then see how that extends to code in some mind-blowing ways. Imagine building this Lego spaceship. It's composed of smaller and smaller chunks or blocks. In code, we can also create distinct chunks or blocks using functions, classes, modules, libraries, folders, even entire code bases. That's a lot of ways to group code into reusable blocks. So let's start simple with basic functions in Python. So you're taking a starting value, in this case 42, and running 2 complex calculations with it. Just like how a handful of Lego bricks is hard to keep in your hands, a lot of lines of code are hard to hold in our heads. What can we do? Well, we can group those codes into 2 functions for each calculation. This creates a simplified interface around the complex calculations. We just have to pass in a value and not have to worry about all the details of the calculation itself, which makes it really easy to combine these functions into something even bigger. If you're half as overexcitable as me, you're probably thinking, whoa, I'm ready to go build functions into classes and modules and libraries and code bases. Not so fast. Pay attention because this next part is what the noobs usually miss. If you want to build bigger blocks out of smaller blocks and have everything actually work, unlike this, you're going to need to understand how to build interfaces that are clean, clear, and even fun to use. But what exactly are interfaces in code and Lego, and why are they so important to building bigger and bigger systems? In Lego, the basic blocks are easy to combine and separate because they share a common interface. The same thing holds for the composite Lego blocks. For example, this body exposes 2 blue axles that help it interface cleanly with the corresponding 2 holes in the wing. In code, it's also easy to group basic lines of code into a function, class, or module. And it should also be easy to compose those bigger bricks with nice, clean interfaces. Here are some specific examples of what I mean. In Python, you might wrap complex calculations in a class, then expose only a simple method to use. Even if the underlying implementation of that method changes, that public interface can remain the same for whoever is using it. On an even higher level, front-end libraries and frameworks like React or Vue wrap the complexities of how you update a web page's DOM guts and provide instead a simplified interface for managing the UI. Finally, when building a UI that, say, displays data in a variety of ways, you might give all the components that display data the same 2 parameters, name and value, for example. so they can easily be swapped with each other. This way of creating standard interfaces between bricks opens up a ton of flexibility in whatever you're building. I just showed you some small individual examples, so let's bring it all together by doing a big project. To continue the spaceship theme, let's build a spaceship dashboard with a speedometer and two sections, one with information about the left wing and one with information about the right wing. Now, without the Lego principle, I might be tempted to just dive straight in and code up this entire dashboard in one go, which might result in an experience kind of like this. Now let's code this thing up in HTML.
30 seconds of pure skill later.
And done! So, wait, why is this side way smaller than the other side? And shoot, what is going on with this row? I know, I'll just tweak the HTML really quickly. Here, and oh my gosh, what is even going on in here? Lego principle to the rescue! Applying the Lego principle to code a visual interface is particularly fun. The nested blocks of the web page itself, which you can see in front of your eyes, already start to hint at the nested bricks you'll need to write to build that web page. For example, I can create a code block called wing info header and another code block called info row, and then compose those together to create a larger wing info panel. Now, a code noob could have conceivably done the kind of brick decomposition and composition we just talked about. So let's go deeper into the mind of a skilled engineer. Beyond just the visual interface of the dashboard, a skilled engineer is thinking about the code interface of that dashboard in two very specific ways. The first interface I'm thinking about is mostly designed for me. It's the one provided by the library or framework I'm using to build the visual interface. In my case, it's React. What kind of interface does React have? Well, bricks are the fundamental pieces of building with Lego, and functions are the fundamental pieces of building in React. Specifically, functions that take in information and return chunks of the web page. React goes one step further. It actually takes those regular JavaScript functions and gives them a new, shinier interface that makes them look a lot like HTML. Millions of programmers around the world have chosen React specifically because that interface is clear and fun to use. When you think about the core members who are building React, they're not just programmers. They are user interface designers. The second interface I'm thinking about as I build this dashboard is one that I am largely the designer of. Specifically, components that I want to be able to easily swap in and out. In this project, that's really the wing info rows. Now, if you look closely, there is a pattern. They all have a name and a value. Now, if I standardize that pattern, something amazing happens. Say I want to take the angle and render it as a speedometer-like visualization. Now, it could take me days to code that up, but I can actually go onto Node Package Manager, or NPM, and search for a package or brick that some other developer has built, install it, wrap the installed speedometer component in another slight component that has the exact same interface as the info rows do, and drop it right into my code just by changing the name of the brick or component for the angle section. And just like that, gauge is not defined? Come on, oh. Voila! I've added that piece in, and my dashboard is looking better, all thanks to the Lego principle. You realize what just happened? I was using the Lego principle, and then I just seamlessly pulled in a brick written by someone I'd never even met and used it flawlessly. That is the true power the Lego principle enables. I can work with my own code pieces. I can work with the code pieces of a teammate. I can work with the code pieces of someone across the other side of my entire organization. I can work with someone on the other side of the world. I can work with alien civilizations light years away. I thought the aliens part was actually really... Okay, thanks, Michelle. And that's why, as important as understanding the syntax of a given programming language is, it's just as important to understand how bricks are built and shared across it. And when you think about that, suddenly a thread lights up between every major programming language. They all have a brick manager or a package manager, some way to easily share and use bricks created by others. When you work in JavaScript, there's the node package manager, or NPM, which stores all of the bricks you're borrowing in a package.json file. For Python, there is pip, storing bricks you're using from others in a requirements.txt file. Ruby has Ruby gems stored in a gem file. Java has Maven. PHP has Pear. C++ has Conan. And Swift has CocoaPods. Early on in my programming career, I just treated package managers as this confusing, annoying thing I had to know the minimum stuff about. But get to know it, because it is your doorway into the genius of others, and ultimately for you to share your genius with those around you. It's the final interface in programming, the connection between you and alien civilization. No, there's no alien stuff anywhere else in the video. Or other people who are smarter than you. From individual code group into Python functions to package managers enabling terrestrial collaboration, the Lego principle is incredibly powerful at all levels. Why is that? It's because the Lego principle is not something invented just for code. It's actually an imitation of how the universe itself functions. From cells forming organs, to forming mammals, to quarks and atoms and molecules. The world is composed of units, systems made of distinct pieces building something bigger than themselves. And so when we code, we are not just using arbitrary principles. We are participating in the creation that we see all around us.